Good morning. I'm John Eastman, project engineer for the Optimizer 2 breaker monitor. Today I want to stick to the facts and show you how this new product is helping other utilities around the world save money on maintenance and get better performance from their switchgear. Let's start with a brief review. As most of us know, the utility is set up like the chart on the left. You have power plants, and then voltage is stepped up and transmitted on transmission lines, and then it's stepped down when it gets to where it's needed and distributed to homes, factories, hotels, and other bulk users and retail users. And somewhere about the middle line, you have the distribution level of transmission of electricity. To the right is a picture of a small rural substation. Inside this substation, we find a circuit breaker that's being installed as a replacement for a bulk oil circuit breaker. And this goes out to a feeder that feeds a small town. So on a circuit breaker, what mechanical metrics should we be measuring? Well, certainly all the timings that we can get, which would include trip and travel, clearing, arcing, and closing times. These are all mechanical aspects. Another good piece of information is the number of days since the last breaker operation. In hot weather, we know that lubrication can harden up and become less effective if it's not continually smeared on the bearing surfaces of the mechanism. So that's a nice piece of information. We also would like to know the arc duration and peak primary current during a trip. From these things, we can calculate the remaining contact life, and we also look for restrikes, which is important, particularly for a vacuum breaker or any breaker that's controlling an inductor or a capacitor bank. Restrikes on these systems are very detrimental to power quality. We would also like to know real-time current measurement, and we would like to know if there's a problem with the auxiliary switches that would indicate a breaker failure of some kind. Here we have a video of circuit breaker format. Now normally this operation would just take a matter of milliseconds, but this is just to show you what the inside looks like. Of course, all the interstitial space is filled with SF6 gas. The large silver contact around the outside is the main contact, and there's an arcing contact inside that gray cone. And so those are the two primary components of the circuit breaker. Ready?
So that was a close. Closing, okay.
Next operation is an open or a trip. Ready? The lights turn up.
So as we can see, there's a lot of shock and vibration involved with the operation of a circuit breaker. You weren't standing there, but it was incredibly loud, and that whole cabinet shook and vibrated every time it operates. So the monitor itself has to be built pretty rugged to survive that. All right, here's another view of that moving contact. As again, I said the round contacts around the outside, those are the mains, and that prong in the middle is the arcing contact, and that is really what should be taking the brunt of the arcing. We don't want to see arcing on the main contact because it can be really bad really quick. So the arcing should be confined to inside and on that prong alone. It's a sacrificial contact, as they say. Here's another example of a different type of circuit breaker. This is also SF6, but extremely high current. This is for generator main, so it's very high current, not so high a voltage. But on a breaker like this, new, these things cost about $1 million, and 1 millimeter difference on the arcing contact can mean hundreds of thousands of dollars difference in the cost of a rebuild. You want to keep the arcing to the sacrificial contact and not have it occur on the mains, which are around this arcing contact, similar to the one before. So what is SF6 gas, and who really cares? Let's review it. So SF6 stands for sulfur hexafluoride, and this is a picture of the molecule. And it's a very stable molecule, very tightly bonded. People use it because it's an excellent electrical insulator. Okay, so at 3 times atmospheric pressure, it's 10 times better than dry air as an insulator. So if you're talking about a circuit breaker, an arc that would be the size of say a soccer ball or a basketball in dry air will be the size of a golf ball in SF6, and that's why the size of those contacts, that's why they're sized the way they are. A golf ball will fit inside there, but say the gas went away, you would have it try to operate, but the breaker would likely explode if it had no gas. Could not be made as small. So why is SF6 gas such a good insulator? Well, it's strongly electronegative. So there's 3 major aspects here. It catches free electrons that would be provided by an arc, and it quenches them. Okay, so when the molecule of SF6 is blasted apart by the energy, it uses energy. So there's energy sunk in destroying the molecule. So this energy goes into that and thereby provides a cooling effect. And another good thing is after the arc event is over, the gas recombines. So there's a self-healing effect going on. And there's also other byproducts, is that it's non-toxic to breathe. You might suffocate, but there's nothing chemically there that will kill you. It's non-flammable as well, it's inert. But every rose has its thorns. And the problem with SF6 gas is that it is 24,000 times worse than carbon dioxide for its effects as a greenhouse gas. All right, so let's look at some problems and see how the optimizer might solve them. Okay, so problem 1. Say you're Jamaica Public Service, and you have these 10 areas where you have power plants and high load centers. If you need to report your SF6 gas emissions to the IPCC, how are you going to do it efficiently? Are you going to drive around to all 10 substations or more and record gauges and meters? That would take a long time. So for us, the solution is automated record keeping. If you have an optimizer on your circuit breakers, it will automatically calculate how much gas has leaked to the atmosphere, and it will also give it to you as an equivalent CO2 calculation. So this would be one way. An even better way would be to directly import the data from the optimizer into your IPCC database that's provided by the IPCC. This is a screenshot of you're tallying all the different greenhouse gases, and this is a screenshot of SF6 in particular. And because the file format is well known to us, if you were connected up with the Ethernet and had connectivity, you could directly import the information from the optimizers out in the field to this database for submission to the authorities. Let's take a look at some raw data, okay? So here's a plot of temperature and density over a time of about 261 days. You can see that the red is the temperature and the blue is the gas density. Okay, so let's take a look at this. So through the middle of the plot, it's quite hot out. It's close to 100 degrees Fahrenheit. It's between 40 and 50 degrees C. And we can see the blue trace is falling, which indicates a leak. Okay, as the density goes down, you're leaking. One thing we notice right away is that it leaks slower during hot weather, and it leaks faster during cold weather. So this is a good diagnostic piece of information to know that it's likely a seal and not a casting problem. Seals tend to shrink and swell with temperature. So we calculate all these different refills where the density has been rapidly increased, and we calculate how much is put in for the lifetime of the breaker. So in this case, in 261 days on this leaking breaker, 43 pounds of SF6 has been added. And said another way, that means 43 pounds of SF6 lost to the atmosphere. So what is it? Well, the CO2 equivalent is 2 hours of CO2 produced by this 1,000 megawatt coal plant. So here's another problem. Your management's asking you to reduce labor costs for maintenance and also extend your breaker life. Everybody wants more life and more service from their capital investment. But how do you do it? Looking at this graph, you have a couple of choices for maintenance. The blue line would be sort of the old style calendar-based maintenance, where you do the same thing no matter what kind of activity the equipment had, whether it tripped a lot or tripped a little or never tripped. You go out there and do the same things every year. So that's a fixed cost, and that's why it's shown here as a straight line, just accumulates at a constant rate. If we look at condition-based maintenance, this would be a strategy where you measure specific things around a piece of equipment, whether it be a breaker or a transformer or many other things you can monitor in a utility, but we're talking about breakers here. So for condition-based, there's a higher initial cost, meaning you have to add some monitoring equipment, maybe a few sensors, and there's a little labor involved. But as these things get installed, condition-based maintenance is much less expensive. So most utilities have found that there is some combination of calendar-based regular maintenance and condition-based special maintenance. There's a combination which provides the perfect blend. Okay, and that would be indicated by the red line down in the trough. You do just enough calendar-based maintenance and just enough condition-based, and you get the minimum. So right there, you're getting the most you can out of the piece of equipment for the least outlay of labor and added parts. So if we take a look at what's provided by the optimizer monitor, another way to look at this is you can direct maintenance for filling of leaking breakers. And you do this by looking at the gas fill forecast. And this is available right out of the monitor, which is right on the breaker. Here, this one is telling you you have 83 days to refill the breaker at the given leak rate before it goes into low gas lockout. Okay, so this is an excellent planning tool, if for nothing else than to plan your refills on straight time rather than waiting to react to a middle of the night panic alarm. Okay, it's much less expensive to plan it ahead. You have the materials, you have the crew, the truck's available, and you refill it on a Thursday afternoon rather than a Sunday morning. Makes a big difference. It only takes a few avoided after-hours calls to completely pay for the system. Another solution here that's offered by the optimizer to get this life extension that we talked about is to limit how much you need to refill the breaker. Okay, detecting a leak is really more about finding the leak and repairing it than it is knowing when to refill it, because you really don't want to be refilling it all the time, especially in humid climates where moisture will ride into the breaker on hoses, connectors, and even the storage cases, the foam inserts that you put all these parts and pieces in, they hold moisture, and every time you refill with gas, you're sending more moisture into the breaker that really wants to be dry. So the problem is the moisture mixes with the arcing byproducts inside the breaker. Particularly the ablated Teflon nozzle makes some very caustic, nasty substances that corrode the metal very quickly. Here's a breaker that suffered such a fate. All right, this middle phase here blew up. It blew out the side and blew out the bottom. And when they took the other two phases apart, they realized that there was standing water in the other two phases. And it was primarily due to continual refills. And the desiccant bags were also completely saturated in these breakers. So this was a failure that occurred just randomly. This picture doesn't show it, but it was quite a violent explosion. It took out some sheds on some standoffs and some of the surrounding equipment. It made the news, and it was the kind of publicity the utility really didn't want. All right, so what about the labor to install these things? Utilities are wary of monitors and other devices that require a lot of labor to install. And yes, if these things aren't thought out in advance, it can take a lot of labor, but we've brought all our experience to bear to provide pre-engineered kits that help you install these things in under 2 hours per breaker. So with our 25 years of experience, we know very well what is required for most types of gas puffer circuit breakers. So for instance, here is an ABB PM style breaker. Okay, we've pre-engineered this tubing and retrofit kits for the sensors, and it makes it very easy for a field crew to install. You can see the picture in the middle is the actual part, and on the right is the part installed, and on the far right of that picture is the silver gas sensor that we use. Okay, so for Mitsubishi breakers, we have a pre-engineered kit for it as well. It's in the baggie in the middle. It comes all with all the parts you need for most Mitsubishi breakers that we've seen. And on the right, you can see a typical Mitsubishi installation. It's very simple when you have the right parts. So let's shift gears here and talk about breaker monitoring in general. The market has always had an interest in monitoring from the standpoint of protecting the equipment. Okay, we don't want the equipment to operate when it doesn't have any gas in it, because we know what happens. But now the focus is more on the environment. We want to protect the environment from gas leaks. Okay, so we're looking at the gas. What should we be measuring? Well, for us, we think it's important to measure the density of the gas. Density is a measurement that's independent of temperature and pressure. It's a measure of the amount of molecules in a given space. So we use a very sophisticated new sensor that monitors density directly. So it's very accurate and minimizes false alarms. Okay, it is nice to know the temperature, if for nothing else to know the cabinet temperature where these are usually installed. So we'd want to take this data and calculate the change in density, which would give you the rate of decrease and trending of any leaks. From that, we can forecast a refill requirement. For instance, as we showed before, days until low gas lockout. We also want to mimic the low gas pressure switches, so we can alarm to static pressures, a warning and a lockout level. A very important thing we do is to totalize the fugitive gas emissions for a defined time period. So this is the data you'll need for IPCC reporting. In the future, it will become more important to measure the moisture content of the gas. As we said before, moisture in a circuit breaker is bad news from many standpoints, but primarily that it mixes with the gas byproducts and creates a very caustic atmosphere for the moving parts. So as moisture sensor technology improves, we can easily add it to the optimizer and have it be an alarmable feature. So here's the basic system. You have the optimizer box that mounts inside the control cabinet of the circuit breaker. We have a digital gas density sensor, and then it also includes 3 snap-on current sensors which snap around your bushing CT secondary circuits. The general features are that it's proven. We've been at this 25 years, and for 15 years it has been one version or other of this optimizer. Today it's called the Optimizer 2. Another feature is that it's very easy to retrofit to an existing breaker in the field, as we already mentioned. But it's very easy also to specify it on a new circuit breaker from a vendor. Okay? They've all seen it, and we're in the approval process at 3 breaker manufacturers and have been approved at 3 others. So it's very well accepted and well known. It offers visual displays and local alarms for field crew action and response. Okay? So we're able to empower the field crew and give them the information they need to schedule work on breakers and also to protect the environment. If they see a breaker that's leaking, they're a first responder. So we need to empower them and give them the information that they need. More about that later. We're using state-of-the-art SF6 sensors. They're digital. We can also use analog 4 to 20 pressure sensors or new hybrid sensors, which are both analog and digital. Our device is powered from either station DC or AC. And some of the new features that we have are that it's communicated via a web browser. There's no PC software to maintain. All you need is Microsoft Explorer or some other web browser, be it Chrome or Firefox. Any of them will work. We also have included DNP3 communications protocol. You can get that via RS-485 or Ethernet. You can also download information and upload programming via a USB port. And later this year, we'll be offering IEC 61850, which is the new high-speed standard for substation communications. As it is now, we have many communications options. As I mentioned, we have local data access via some LEDs, USB memory stick. Wired access would include Ethernet, alarm contacts for existing RTUs. You can use serial 232, 485. You can use both of them at the same time, talking DNP3. We have many users that are using radios and some that are using sort of a smartphone device where we're putting the information up using a wireless web hub. And as the person to the right is accessing it with his BlackBerry smartphone. And this is a trend we see in the United States where field crews are being issued smartphones as a man-machine interface for these IEDs. Something new we're working with is something called the PCS system by Dynamic Ratings. And this is a power line carrier communications link where there is no digging, trenching, or wiring required. You have one of these little boxes at each end, and it inductively couples the signal communications via your DC supply line. It's just as if you had an Ethernet wire between the optimizer and your hub inside the substation building. It takes about 15 minutes to install it, and you're done, and it's completely secure. So say you want to use a web browser. This is sort of the brute force method for programming, but here's your status screen, which is where you land when you log on to one. It has an IP address, and you can access all your alarms, and you can drill down to specific alarms and get data. You can see here that you have current gas density and how many days you have before you need to refill. It's all right here on the landing screen. Say you have a batch of breakers that are all the same. You can program one and use the USB memory stick to clone them. You plug it into the first one that's programmed, and then you just go down the line and plug it into the virgin units, and they get programmed exactly like the first, over and over again. Makes it very easy to set up. And if you have questions on setup, we have all the settings in our library. So they're easily accessed by a phone call to us or an email. We can even email you the exact settings you would put on this stick, and then you can go to the field and program them. So comparing this technology to what protective relays may offer, we find that protective relays miss these important benefits that we offer. Okay, we detect leading indicators of breaker failure. Okay, we're looking at speeds, and we can see trends of speeds, and we're looking at gas density, very sensitive to gas leaks. All that protective relays can really offer you is to tell you when it's already failed. A breaker failure scheme really is more of a panic alarm versus a planning tool. So it's really not that valuable. Okay, so the optimizer gives you actionable information available locally to the field crews that can use it right away. Another nice aspect of the optimizer is distributed intelligence. The life history is on the breaker. It's not controlled by your IT department or your protection and control department. The breaker department, the substation equipment department owns it, and it travels with the breaker. Say you reconfigured a substation and moved a breaker. You wouldn't have to get IT involved. The optimizer is on the breaker, and it will save the information, whether it's powered down and moved. It's like the memory bank for a given circuit breaker. It seems ludicrous that today we have these high-tech, high-speed breakers that will last 50 years, but there's nothing on them that has any intelligence until now. Another nice feature is that all processing is included in the monitor. There's no analysis software, no PC software to maintain, and we're not tied to Microsoft. So every time Microsoft makes a change to an operating system, it doesn't affect us. You can use any internet web browser and log on to our device. Okay, so Incon is an independent third party compared to breaker manufacturers and protective relay manufacturers. So we're not a sole source, and a third party can honestly give you leak warranty validation. Okay, so if you're looking for 0.1% leak rate out of your circuit breakers, and that's what the warranty says, you can know with certainty whether or not the warranty is something you need to look into. Say you're leaking, and you can check up on these manufacturers and these claims. And probably the best thing is that this product is produced by the pioneer in breaker monitoring. Okay, it's supported by breaker experts, not relay programmers. So when you call us at Incon or email us with a question, you're talking to people that really know circuit breakers, have field experience, have experience with diagnostics and testing in the field, and that matters. As I mentioned before, all the OEMs are familiar with us. Of course, after 25 years, they would know us. And we work intimately and have worked very closely with them on the development of the optimizer too. So here's one at Siemens going out the door in their factory. Here's some testing that's going on presently at Alstom in Pennsylvania. This is a 550 kV independent pole operated breaker, and in the cabinet below is the optimizer, and they're very pleased with it so far, and they've tested it beyond 15,000 operations and all the vibrations and everything with it so far. They're very pleased. We've had a number of field successes. This is during our initial testing phase last year. This is in northern Minnesota, which is sort of near Canada, so it gets quite cold. Here's another one that's even colder. It's in Alaska. This is on a Mitsubishi circuit breaker, a couple different ones. Here's one in a hot area, San Antonio, Texas. This is on an ABB PM style. Here's one in Oklahoma. That would be in the Midwest, United States. And here we're trying out some new labor-saving methods. We're using a magnetic mount to mount it on the cabinet. And we had a prefabbed plumbing piece. And this installation took less than 2 hours, including the switching out of the breaker and grounding it and opening up the switches. So went very quickly. To review the benefits, the optimizer automates compliance for IPCC reporting, meaning you know exactly how much gas your circuit breakers have released into the atmosphere. And you can also separate that from handling losses. Okay? So now you have a way, if your handling losses are large, you need to direct some resources into gas handling, maybe equipment, maybe some crew training on how to handle the gas, and not lump it all together as a loss. But now you can actually separate it. So we totalize the SF6 emissions for the entire lifetime of the breaker. Probably the most important tool of the whole device is to forecast when you will need to refill the breaker with gas. It's a huge labor savings and planning tool. Okay, we issue alarm for incipient breaker problems, meaning breaker problems that are going to happen in the future, but we see early clues that there are problems coming up. We give fault service data and peak currents, particularly important for generator main breakers, where just a few operations, too many, costs a huge amount of money in terms of a rebuild. If you get it in time, it's $100,000. If you don't get it in time, it's a $500,000 rebuild. So there's huge leverage in actually measuring these currents. The optimizer is accessible through your networks, whether it's Ethernet or any sort of internal network. You can hook it up to your SCADA system, or you can put the whole thing on the internet. It's applicable system-wide to any circuit breaker, via a bulk oil circuit breaker, SF6 puffer, air blast, or live tank breaker, even a circuit switcher, which is basically a live tank breaker. So you can use it system-wide. Well, thank you very much. We really appreciate you allowing us to tell you about this new tool, and I'll open it up to any questions you may have. Thank you very much.